Next slide. So this is the F statistic for the within subjects ANOVA. Again, we have the MS between, the variance between time points, divided by the variance for the error portion. So this is what we are trying to get in the end. So this is our goal here. Let's try to get this F statistic. And remember, we subtracted out the variance due to the individual differences. So the individual differences we want to remove. So our test will be hopefully more powerful. So first you want to get the MS between. So remember, we have our F-STAT's going to be the MS between divided by the MS error. So we're trying to get this top part right now. And to do that, it's very similar to the between subjects ANOVA. We're just going to do it specifically for time points instead of just for the groups. Or the groups are the time points. So you want to get the sample mean for each time point. So for time point 1 it was 4, for time point 2 it was 10.5, for time point 3 it was 14, and then you want to get the deviation from the grand mean. The grand mean was 9.5, so you do 4 minus 9.5, 10.5 minus 9.5, and 14 minus 9.5. Then you square those answers to get rid of the negatives here. And then again we want to take in account the number of subjects. So remember, there's 3 time points and 4 subjects. So 3 times 4 gives you 12 total scores. So essentially what you're doing is taking the 30.25 and adding it 4 times, because you need to do this for each subject, and you do that same thing for 1 and 20.25, but instead of writing that all out, 30 plus 30 plus 30 plus 30 plus 30, whatever, you just times it by 4. And you want to do it for each observation, because I mean that's what you do when you do the sum of squares within, you do it for each observation. Okay, so it makes it comparable. So once you do this, you multiply the number of subjects times your squares. Then you add it all up to get the sum of squares between. And then finally you want to get the MS between, which is the variance between time points. Between time points. So the MS between is the variance between time points, basically. It takes into account the sample sizes though. So it's the sum of squares between divided by the number of groups, or the number we can put here, time points, minus 1. And so we get 203. And then we have 3 time points minus 1, so that's 2. So 203 divided by 2 is 101.5, and that's basically the variance between the time points. And we want to see if this variance between the time points is statistically significant, and if it is, if it's big enough, then that indicates that there is a difference in the average scores for each of the time points. So next, we want to get the MS error. So remember, the F for the within subjects ANOVAs is the MSB, or between time points, divided by the MS error. So the error, remember, is the within, but taking out the variability for the subjects. So here we have it, and so remember we already got the MS between. So now we want to get the bottom portion. The MS error is just the sum of squares error divided by its degrees of freedom. That's really not too much of a surprise here. The sum of squares error is the sum of squares within minus the sum of squares subjects. So remember that pie chart that we had. The within is basically the variability due to the subjects or the individual differences plus some unexplained error that we don't know what it's from. So if you rearrange this, you'll get this formula here. And then degrees of freedom error, a little bit weird, but you get the number of time points minus 1 times the number of subjects minus 1. We'll go through an example here. So you can do this in a couple ways, but I'll show you this way. So you can get the sum of squares within as usual. So this is just the sum of squares 1 plus the sum of squares for time point 2 plus the sum of squares for time point 3. And that should give you 35. You can see the handout if you want to see how I got each of these. So it's just the variability within the time points. Or toilet paper. Alright, then you want to get the SF subjects, which is the variability due to the individual differences. Okay, so it's very similar to getting the sum of squares between, but now instead of getting sample means for the time points, we're going to do it by the subject. So here's the sample means per subject. So subject 1 for each of the time points had a mean of 7.33. Subject 2 had a mean of 9.33, and subject 3 had a mean of 12. Subject 4 of 9.33. Then we can find the deviation from the grand mean for each of the means for the subject. So 7.3 minus 9.5, 9.3 minus 9.5, 12 minus 9.5, and 9.33 minus 9.5 again. And then we square those values. And then what's a little bit different is we're going to do the number of time points times whatever the squares. So we want to make sure that, you know, we're kind of doing this 12 times again. And so if you add this last column all together, we'll get 33. So this is the variability due to the individual differences. It's just like the total variability. And then in a second we're going to get kind of the variance by dividing the degrees of freedom. And so we have, remember the sum of squares error is the sum of squares within minus the subjects. So if you remember, we got 35 for the sum of squares within, and we got 33 for the sum of squares subjects. And we're left with just 2. The degrees of freedom error is the number of time points, which is 3 minus 1, times the number of subjects, which is 4 minus, and then minus 1. So then we get 2 times 3, which is 6. Remember your order of operations, subtract first, then multiply. And then we take this, and then we get this MS error, so it's the sum of squares error, which was 2, divided by its degrees of freedom was 6. So we get 0.33. Then finally, you want to get your F statistic, which is the MS between divided by the MS error. So you get 101.5 divided by 0.33. And this is 307.57. I don't know if this is significant. We can get the exact p-value in Excel. But we'll know that the p-value is less than our 0.05, which is kind of our standard alpha level. So it's significant, so we can say something like there is statistically significant evidence conclude, there's a difference in the averages for the time points. Remember, on the top is the variability for the time points, and we removed the variability for the subjects. So it's not about is there variability in the subjects. We just removed it to make our F-statistic more clear and more powerful. Okay, so just remember that when you're interpreting this, where we want to know if there's a significant difference for the time points, and remove the individual differences to make the F-statistic more powerful for us. And so if you write this out, and then the last thing you might want to do is do a follow-up t-test. And because it's paired, you want to do the dependent version. And so you want to compare 1 versus 2, 1 versus 3, and 2 versus 3. That would be your last step. And that concludes this video. Make sure you read the handout.